Welcome to our presentation. So I am Farelia Octa Viola, and my friend Stevani Manik would like to explain about the golden ratio. So let's get to know the content of this video. First, we would like to explain about the legend of golden ratio. In here, we would like to make it clear about the history of golden ratio and why it became famous like now. And the second is mathematical properties of the golden ratio. And the third is about the misconception about golden ratio's appearance in art, architecture, and nature, specifically in Myth 3 and Myth 4 in number theory books. And the fourth is the plant phyllotaxis, one place golden ratio really does crop up in nature. So let's move to the history of golden ratio. Let's get the ball rolling. So what is the golden ratio and why is it important? Golden ratio, also known as the golden section, golden mean, or defined proportion. In mathematics, the irrational number 1 plus square root of 5 over 2, often denoted by the Greek letter like that, which is approximately equal to 1.618. It is the ratio of a line segment cut into two pieces of different lengths such that the ratio of the whole segment to that of the longer segment is equal to the ratio of the longer segment to the shorter segment. So in here I pick a picture in which shows the golden ratio itself, in which showing that 1 over b is equal to 1 plus b over a, and it's equal to 1.618, which is the golden ratio itself. So maybe you asking why is it 1.618? So it refers to the Fibonacci sequence that remains constant ratio, which is 1.61, no matter how long we follow it. So we know that the Fibonacci sequence is 1, 2, 3, 5, 8, 13, and if we find the ratio of the Fibonacci sequence, we will see that the value remains constant ratio, which is 1.61. You can see in the picture. And then next, so the story behind the famous of golden ratio. It has been said that art, architecture, and nature are more appealing to the eye when the proportion of designs and structures are based on the golden ratio. The golden ratio was popularized in the Renaissance era, and the artists of that period sought to ensure that it was used to deliver aesthetically pleasing works. And today, we still use the golden ratio in our web and app designs to improve the layout and appeal to the eye, and placing full confidence in the time-honored fact. So this is the example of golden ratio. So we can see that Earth is also aesthetically pleasing, and we can find that it is actually golden ratio. And also our hand, you can see that our hand also a golden ratio, and many more. And then the second part would like to explain by Stevani.
Thank you, Viola. And the next one, we will continue to the mathematical properties of the golden ratio. Okay, in the previous explanation from the previous group, we know that the golden ratio squares minus golden ratio minus 1 it's equals to 0. And when we factor it out, we get the golden ratio, it's equals to 1 plus minus square root of 5 over 2. When it's become positive, the golden ratio, it's equals to 1 plus square root of 5 over 2, which is approximate to 1.6180 something. When it's going to the negative golden ratio, it's become 1 minus square root of 5 over 2, or approximate to minus 0.618 something. Okay, from this result, we know that golden ratio minus 1, it's equals to minus negative golden ratio, which is equals to 0.6180 something, right? As you can see in this result, right? But not only that, we can find also that the golden ratio minus 1, it's equals to 1 over golden ratio. So you can see in this beautiful pattern. Not end with it, golden ratio that we know is equals to 1.6180 something, it will be same result with 1 plus square root of 1 plus square root of 1 plus something something. It will repeat it. Square root of 1 plus square root of 1 square root of 1 until the end. The result will be same. And in the ratio number, in the quotient number, the golden ratio will be equals to 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus something. It will repeat it too. And look at this pattern. This pattern will bring you to the golden ratio, which is 1.618 something. So that's why it's become golden ratio, because the beauty of the number itself. Sorry, Viola, you forget to unmute yourself.
Thank you, Steph. So now I would like to explain about misconceptions about golden ratios appearance in art, architecture, and nature, specifically about myth 3 and myth 4. So next, in myth 3, it states that many famous works of art, including some by Leonardo da Vinci, were based on the golden ratio. So it is not completely true. So there is works by Leonardo da Vinci were based on the golden ratio, but not all. And finding the golden ratio in these paintings would require fudging measurement and or arbitrary selection of measurement points. And and there are many different points in a painting from which distances can be measured. And furthermore, the historical states that the golden ratio in art are without foundation. So in other words, it is not founded by the existence of art. However, some modern artists have inspired by the golden ratio and the legend that surround it.
Okay, with the fourth myth, we met that the golden ratio is present in human body and in many animals form. So this is myth. Okay, let's move to the human first. One of the human golden ratios states that the total of our height over the height of our belly button, it will brings you to the golden ratio. But this is actually myth. Why? Because the first, there are so many different parts. We know that there are different parts that we can use to find out the golden ratio, which is not have a specific rules. Like we can use our arm, we can use our length, our body, and others. And the different parts could bring the measurement roughly equals to the ratio. Just roughly equals, but do not exactly equals. Okay. The second one, each person will yield different ratio. So the length of my body parts is definitely different to your body parts. The situation makes some people's ratio might be equal to the golden ratio and some people might not. Finally, for body parts are not points but physical feature in non-zero size. For example, when I'm measuring the ratio for from elbow to fingertips, which point from the I will questioning which points from the elbow to measure for and which finger to measure to the tip. So there is no exact rules to the measure the length. Okay, so we move to the animals. This is also myth to the animals. Why? Because the first one, even in the same species, different individual animals have a variety of shapes. Okay, so the ratio just would be approximate to the golden ratio and do not equals to the golden ratio, right? And yeah, the same species will have a different variety of shapes and will bring you to the different result of a golden ratio, of course. And the second reason is animals' appendages, such as wings, can be positioned in a wide range of position. There are a lot of different body parts, and the golden ratio hunter could choose whichever position yields the golden ratio. So that's why it is made, because there are no exact rules, and yeah, we do not use golden ratio as our perfect body parts, because different person have a different length. Okay, the next one, we will continue to the plant hypothesis. Plant hypothesis, one place golden ratio does crop up in nature. Okay. So, in this picture, we can see how the golden ratio fits with the nature. Fibonacci numbers appear in a number of plant forms, such as in this picture, in the spiral pattern of their leaves, petals, buds, fruits, or florets. The biologists and mathematicians have determined that Fibonacci spirals emerge as a consequence of the Fibonacci spirals form at a particular constant angle around the appendix from the previous one. You see in this picture? And this angular interval is 30 60 degrees over golden ratio, which is the angle that divides a circle into golden section. So golden ratio is really close to us. We can see in the nature, in the plants, and others. Okay, that's all for our presentation. Thank you for your attention. Have a good day.